We are going to talk about holes in the graph of a rational function. Now, a hole in a graph is just a point where it looks like the graph is going through that point. However, right at that value, that x value, our function is actually not defined. And so we get what's called a hole. So to find holes in a rational function, what we need to look at is the reduced form of the function. So we're going to let this lowercase r denote the reduced form of the rational function, capital R, and we compare the domains of these. Okay, if x equals c is not in the domain of the original function, but it is in the domain of the reduced form, then the graph of r of x, capital R of x, has a hole. And that hole is at that x value, x equals c, and the y value is what we get when we plug c into the reduced form of x. So let me give you a quick example here. So suppose you have x squared plus 2x, and we have x squared minus 4. Okay, and this is our rational function, r of x. So what we do, the easiest way to go about this is to factor this. Okay, we can factor an x out of the numerator, and we can factor the denominator. That's a difference of squares. Okay, and we cancel. All right, and canceling here, the x plus 2 is in common, and we get our reduced form. Okay, r of x is x over x minus 2. And all you need to do is compare what values am I not allowed to plug into this original r, capital R of x, but I am allowed to plug into this lowercase r reduced form. Okay? And that just comes from what was canceled, specifically what was canceled from the denominator. Okay? What's gone completely from the denominator now is the x plus 2. And that means x equals negative 2 is not in the domain of capital R of x, but it is in the domain of little r of x. Okay? So that means we have a hole at x equals negative 2. And to find that, we plug it into little r of x. Okay? So we get negative 2 over negative 2 minus 2. This is 1/2. So we have a hole at the point negative 2, 1/2. It's a hole. It's not actually a value on the curve. It's not a filled in point, but it's a hole. And so if I were to graph this, okay, we don't know what the rest of the functions looks like, but over at negative 2 and positive 1/2, we have a hole. Okay? And so when graphing this function, it turns out that we end up with this hole instead of a filled-in point there. I'll just sketch the actual function for you so you can see it. It has a vertical asymptote over here at 2 and a horizontal asymptote up at 1. And so it looks like this. It kind of hits that hole and keeps going, okay? And it looks like this. Okay, this is the graph of the function capital R of x. And you'll notice we just draw it like we do normally, but the hole, we just draw it as a hole, okay, there, that we don't actually get to touch that point.